Your Holiness, Venerable Samdang Rinpoche, Venerable Bhikkhus and Bhikkhunis, friends. First of all, I am extremely grateful to Your Holiness for organizing this and to COM for taking the initiative and doing the needful. I think this is very important. Now, all these books that I wrote because there was a load on my mind. I wanted to express something. I wanted to make it known to people. For example, that there are cultural foundations of mathematics. Right? So this sort of thing, the load has gone from my mind. It has become just a physical load now, difficult to carry. So I would like to communicate. And I have a number of points. And maybe I cannot cover all those points in the time available. So, but I have nevertheless put them because I'm sure there are, with all this learned audience, maybe it does not get across immediately. You can consult it later on. So you don't need to watch the screen. You can listen to what I'm saying. I may go through fast, but it is there for your later reference. So I'm going to cover 2 or 3 things: mathematics and zeroism. Zeroism is my term for Shunyavad. Science and Paticca Samuppad. And I will just touch upon Shil, which I think are central elements of Buddhism. Of course, you know better, but I want to talk about the interface with science and with mathematics. So the issue is, how does Buddhism connect to mathematics and science as it is currently taught and practiced? And it is especially for physics and mathematics. Now we know there must be a connection. Why? Because Buddhism is not based on faith. It is based on 2 pramans. There are only 2 accepted valid means of knowledge. One is pratyaksh, and the other is anuman. Pratyaksh and anuman. And those are the 2 means of knowledge accepted also by science in principle. Therefore, there should be a connection in principle. It is important to demonstrate that connection. Why? Because if we see today, science is regarded as valid knowledge. And something which does not agree with science is rejected as invalid. And therefore, we want to demonstrate this connection. And as he said, there are cultural factors in mathematics and in science. And I will try to explain that to the best of my ability. It is a lot, maybe it needs a lot of time, but I hope at least the central idea will get across. So there are cultural influences in present-day mathematics and science. And if we want to make it compatible with Buddhism, it may be necessary to eliminate those cultural influences. To make mathematics truly universal, to make science objective in some sense. So in Buddhist thought, I will focus on only 2 key concepts. One is Shunyavad in connection with mathematics. The other is Paticca Samuppad in connection with science, in connection with physics. I use the word zeroism. Why do I use zeroism in place of Shunyavad? Because the interest is in the practical application of the philosophy. And for that practical application, the reference to the authoritative text is not, I think, so important. There is a lot of controversy. There can be a lot of discussion on what exactly Nagarjuna said, what he did not say. And that discussion is not perhaps relevant to the practical consequences. So zeroism is how I interpret Shunyavad. If somebody disagrees, there is no problem. The practical value of zeroism is still there. So I am talking about the practical value in mathematics. So I said there are cultural factors. So let me start with this. 2 + 2 = 4. where are the cultural factors? It's a simple thing. I'm not going into anything complicated, right? 35 years ago, when I used to be a formal mathematician and I used to teach in Pune University, I used to begin my postgraduate classes in mathematics with 2 plus 2 equal to 4. The idea being that the students should understand the philosophy of mathematics, not just that 2 plus 2 is equal to 4. All right, 2 plus 2 equal to 4. Why is it valid knowledge? Is it valid knowledge? And the typical response is, let us say 2 chairs and 2 chairs make 4 chairs, right? Or 2 apples and 2 apples make 4 apples, or 2 glasses and 2 glasses make 4 glasses. But this is pratyaksh praman. I can see those glasses, I can see those chairs, it is empirical. It is pratyaksh praman. And the problem is, pratyaksh praman is accepted in Buddhism, it is accepted in all schools of Indian thought, all systems of Indian philosophy. It is also accepted in science. But it is not accepted in formal mathematics, which is the mathematics which is today taught in schools and universities, which is what I used to teach in my, when I was a formal mathematician. All right, so this is rejected. Pratyaksh praman is rejected in formal mathematics. Pratyaksh praman is rejected. And what does formal mathematics want? It wants to use anuman or deduction as the sole means of proof.
Do you refer to the appearance and reality? There is sort of differences.
Yes.
There is always gap.
Yes.
So the
Pratyaksh
so that
is
mainly based on appearances.
okay. Okay.
That now Nagarjuna's the philosophical view is there are two truth. Kasa.
Samvriti Satya.
Yeah. I will come to that. I will come to that in a minute. I'll come to that in a minute. The point here is that the demand in present-day mathematics is no connection to pratyaksh. Absolutely, whether appearance or reality, it should not connect to pratyaksh. It should be purely deductive based on some axioms. Peano's axioms or axioms of set theory or something else. And that makes the proof very complicated. To prove 1 plus 1 equal to 2, 2 plus 2 equal to 4 is a bit complicated. 1 plus 1 equal to 2, Whitehead and Russell, who wrote in their Principia Mathematica, they take 378 pages. This is the 378th page from that book, Principia.
Oh, but Russell. Oh, yeah.
So, yeah.
It seems
It is all.
more confusion.
Yes, absolutely. This is what I'm trying to say. That why should 1 plus 1 equal to 2 need so much of, why is it so difficult? Because there is no reference to the pratyaksh, no reference is allowed. And the symbols that are used in formal mathematics lack any intrinsic meaning. So 1 plus 1 could be 0, as in exclusive OR used in computer circuits, or it could be 1 plus 1 equal to 1, as in inclusive OR, again used in computer circuits. So to specify, we must first specify what is this 2, that it is an integer. But what is an integer? There are infinitely many integers. So we must first specify the whole infinity of integers. So formal mathematics brings in the metaphysics of infinity even at the level of 2 plus 2 equal to 4. It is not a simple matter at all of pointing to glasses or chairs or anything else.
That's Dagdun said, "Is the legal matter." That is no sharp. Tanya no shashu zane. 다든제 루시아인 그냥 그러나 봐. 저러. 되고 마다 맞으면 타니베. 자상부 돈에 다 가지고. Right.
Okay. So, a couple of warnings. There is no unique or universal notion of infinity. In the Indian tradition, what was used was non-Archimedean infinities. It is too complicated to explain. I will give you a reference. So there were avyakt fractions that were used by Brahmagupt, but I will not going into that just now. I am just saying there is no unique notion of infinity. Like you can have infinities of Cantor and so on, so multiple notions. And second thing I want to say is that the metaphysics of set theory is so complicated that most professors of mathematics in India do not understand it. The head of the department of IIT, head of the mathematics department could not define a set. And I had the same experience recently in another state. I asked somebody, what is the definition of a set? And they give the NCERT definition, collection of objects, which is a completely wrong definition. So he said, well, I asked him, can there be mathematics with a different philosophy? He said, West has given us a paradise. What is the definition of a set on which this paradise is based, or this has sandy foundations? So there are lots of problems. So better to base on empirical rather than set theory. That's what I'm driving at. Now, I want to explain why this belief is wrong, that you must proceed on anuman or deduction only. All right, this is aspect of classical Buddhist philosophy. Rather than a complicated metaphysics of infinity, Pratyaksh is reliable, that 378 pages of Russell, not reliable.
Russell. Bertrand Russell.
Bertrand Russell. But that is what the West believes, that this metaphysics of infinity is the path to certainty, more solid than Pratyaksh Praman. So why does it reject Pratyaksh Praman? There this question comes that Pratyaksh Praman is fallible.
It is not always right.
Right. One may mistake a snake for a rope or a rope for a snake, which is a common classic example. So it is fallible, but Western philosophy believes deductive proof is infallible and certain. Now that belief is wrong, and therefore the theorems of formal mathematics are not valid knowledge. I will give 3 arguments. The first argument is that they are relative truths, because the truth depends on the hypothesis. The second argument is that logic is not unique. For example, Buddhist Chatushkoti. The third argument is that there may be errors in deductive proof, as has happened historically for centuries. So, deductively proved theorem, I have some axioms. From those axioms, I deduce a theorem, and this is not valid knowledge. Why not? So the first argument from relative truth, this is a Lokayat argument. A man takes wolf's paws, and he goes and makes impressions on the ground. And then he says, wise men will look at the marks and will infer that there was a wolf, but they will be wrong, because that is not the only way wolf's paws can make a mark on the ground. I have come and done it. That is the truth. So this is one example, because they assume the hypothesis that paw marks can only be created by a wolf. I can give you a much more concrete example, which actually took place in science for centuries, in connection with a very important navigational problem, which was the central problem of Western science for centuries. So here is a triangle. The yellow part is the triangle. This is a right-angled triangle because these things, these two lines, the latitude and longitude lines, are meeting at right angles here. Pythagorean theorem is a deductively proved theorem. Let us assume it is not actually, it was proved only by Russell. Let us assume it is a deductively proved theorem. It does not apply here. It does not apply here because the surface of the earth is curved. And how do we know that? We can only know that from pratyaksh, so we don't understand, we don't know whether the hypotheses are valid. So formalists also accept this argument, that the theorems are true only relative to the hypothesis. But the hypothesis of formal mathematics, whether Peano's axioms or set theory, they are metaphysics. And since they are metaphysics, the truth of those hypotheses can never be ascertained. Therefore, they are, it is never going to be valid knowledge. And as Russell himself said, in mathematics, he meant formal mathematics. He assumed that all mathematics must be that. We never know whether what we are saying is true. So second argument, a deductively proved theorem is not valid knowledge because logic is not certain. It's not universal. Now, if you change the logic, if the different logic from the same hypothesis, I can prove different theorems. So Aquinas, Kant, Russell, etc., they were unaware, they were ignorant of the multiplicity. So this Chatushkoti differs from two-valued logic, which is assumed in proofs of formal mathematics, because it's a logic of four alternatives, and you can have something which is true, and also the world is infinite, is both finite and infinite. That is the example given. And that cannot hold in two-valued logic. Neither does it hold in Jain Syadvad. So there is a multiplicity of logics in Indian tradition. We are familiar with it. And we have to apply that and not take somebody else's word who says that two-valued logic is universal. That's not right. Jain Syadvad. Therefore, there is no certitude in the theorems of formal mathematics because of the uncertainty about logic. And which logic? Aquinas said God decides. Logic binds God, and therefore logic is superior even to God. But which logic binds God? He had no answer to that. He did not even ask the question. So how do we select the logic? If we select it on pratyaksh, on empirical grounds, then mathematical proofs are more fallible, deductive proofs are more fallible than empirical proofs. If we select it on, I'm sorry, I think I made a mistake. If we select it on cultural grounds, then mathematical theorems are cultural truths. If we select it on empirical grounds, then they are fallible. Right? The choice of logic is fallible.
제가 로기 보자 거를 봤다. 다 도는 무슨 일 두고 있어요. 얘도 정말 튀나오지.
So there is also an argument from Bugs. I will skip it, but the key point is that the Pythagorean theorem was supposed to have been proved in the elements. But there is no valid deductive proof of the Pythagorean theorem before the 20th century. It is all myth. I have explained this so many times. And it is there in this book, Euclid and Jesus. It is there in other writings. So this is the book. It's available. I will skip this. I'll just quote Bertrand Russell because authority. He said it is a scandal. 100 years ago, he said it's a scandal that Euclid is still being taught to boys in Britain. It is a much bigger scandal that it is still being taught to children in India after 100 years. So the proof of the Pythagorean theorem in the elements is an empirical proof. The fourth proposition is proved empirically, and the proof of that depends on it. It is a complicated thing. It is discussed in cultural foundations and so on in so many places. I won't go into that.
What do you mean by empirical?
Pratyaksh Praman, that you take one triangle, put it on top of another triangle, so that is an empirical proof, not a deductive proof. There is no axiom. The first proposition talks about two arcs intersecting. You see them intersecting, but there is no axiom which says that they should intersect. That is what I mean. You see them intersecting, but it is not derived from axioms by deduction. So let me summarize.
In other words, it is direct experience.
Yes. That is all right.
That's good.
It is not deductive. It is not deductive. That's the point. What is the validity of pratyaksh is a different matter. I accept it is fallible. But deduction does not lead to certainty. That's the point. And there is no deduction in the elements. That is the point. It was thought to be a deductive proof for 800 years by all the scholars in the West, and that thinking was wrong. That is the point. That you can mistake an invalid deductive proof for a valid deductive proof, and this situation becomes more complicated with the four-color theorem and with computer-generated proofs, that no human being can decide whether it is a valid deductive proof. All right, so what is my position? I am saying that we should not rely on pratyaksh praman alone. No. Nor should we rely on anuman alone. But we should use both pratyaksh and anuman as in the Indian mathematical tradition, as in Buddhism, as in science. That is the road to valid knowledge. So this is the point that is being made. This requires a complete change of the mathematical tradition. Because what is done today is formal mathematics. We have to reject it, and we have to go back to a more traditional system. I will go to one more point very quickly to explain the relevance of zeroism. Mathematics, or Ganit, is about useful calculation. It is not about proof alone. It is not about reasoning alone. It is about calculation. So calculation of whatever sort we do necessarily involves inexactitude, approximation. For example, let us take the Pythagorean theorem. This is the theorem. It says that if we have a right-angled triangle, the square on the hypotenuse is equal to the square on the sum of the squares on the sides. So if C is the hypotenuse, then C square is equal to A square plus B square. In Indian tradition, it is stated in terms of the diagonal of a rectangle. If we take the C as the diagonal of a rectangle, A and B are sides, then C square is equal to A square plus B square. That is how it is also stated in Egyptian tradition. That is how it is stated in Iraqi or Babylonian tradition in very ancient tablets. This is how the result is stated for a diagonal of a rectangle. But this form is not useful for calculation.
하나는 주셔. 내 주셔 또 것도 돼. 수시 원절래. 내 영어절래. 영어에서는 한주 줄에. 내 많이 것도 돼. Yes.
Yeah. So, to calculate C from a knowledge of A and B, you need square roots. And Manav Shulba Sutra, for example, 10.10, explicitly states the so-called Pythagorean theorem using square roots. And those square roots are also found in Egyptian tradition, in Iraqi tradition. They are not explicitly stated because the things have not survived. In Indian tradition, this has survived. The point about square roots, what difference does it make? It is inexact. You cannot exactly calculate square root of 2. Because if I calculate square root of 2, it leads to a non-terminating, non-recurrent decimal expansion, or a non-terminating, non-recurrent infinite series. So this is the series I have put down. If you see in your calculator, if you do square root of 2, it will give you 1.414 dot dot dot. Whatever it gives you is not exact, because if you square it again, you will not get back exactly 2. You'll get 1.99999, but not 2. So it is inexact. It is always inexact. It is necessarily inexact if you stop after a finite number of terms, and you cannot sum the infinity. Therefore, the Shulba Sutra declares square root of 2 as savishesh, with a remainder, or anitya, non-eternal. And that is, for all practical purposes, you have to live with that. There is nothing you can do. Without, whether you have formal mathematics or not, for calculation, that's the only thing you can use, whatever theorems you may prove. And I will skip that. There is a point about empirical and so on, that in formal mathematics, it is very complicated. With zeroism, I can point. Here is the diagonal. This is exact. Square root of 2 is an approximation to that. In formal mathematics, I don't have anything to point to. I have to say there is a real number system, a horribly infinite set, each element of which is again a horribly infinite set, and which has no real existence. It is pure metaphysics. And then say that all calculations you can do in reality are erroneous, which is not right. That this Western metaphysics of infinity is the only thing you can have, only correct way to do mathematics. That is what has to be rejected. So this is not unique. I will go into that later on.
If I may clarify another point that is just on the board here, Professor Raju is alluding to the discussion between those who believe in a universe that had a beginning, that was created out of nothing, and those who say that the universe has no beginning. And therefore, there is a metaphysics of infinity related to a beginning, as in the Big Bang, as opposed to a metaphysics which says there is no beginning. And that is a big discussion between creationist religions, like Christianity, for example, and Buddhism, which doesn't announce or, a creation, which doesn't talk about a creation.
Thanks. So I'll skip this business of non-Archimedean arithmetic versus the real number system. It is a little technical. The point is that on Buddhist thought, not only square root of 2, but everything is anitya. The whole world is anitya. So the reference to anything which persists for 2 instants is necessarily inexact. If I were to say, as I was saying 2 minutes ago, but 2 minutes ago I was a different person, you were different people, slightly different. We ignore that difference, that we zero that difference. But the difference is there in reality. So when I use the word I, it is inexact. So for whatever I talk about, I must necessarily take this inexactness into account. I have no way of being exact in the real world. And that is the reality. It is the idealistic position that there is exactitude which is incorrect. So zeroism excels in dealing with this sort of thing, with inexactness, with approximation, and so on. And that is where it is most useful. It should be used. It should be recognized upfront, and it is a realistic philosophy. And I will just mention, to come back to the thing with 2 plus 2 equal to 4 as I started, it is not even there. Even there you cannot find exactitude. Because if we speak of 2 glasses or 2 dogs, those 2 dogs are not identical. But we neglect the difference as irrelevant to the context. And to see the relevance, consider, for example, 2 big gold coins plus 2 small gold coins. How many gold coins is it? What would be a fair exchange? Would it be 5 small coins, or would it be 3 big coins? All right. So that will give you a different kind of an arithmetic. But actually, what would you do? Actually, what would you do? You would not do either of this. You will wait. And you will wait, and then you will say that you will shift to a different model, to a model of fractions. That integers do not apply to this situation, so I will not speak of 2 and 2, I will speak of whatever it weighs, add it, I will use fractions. This is the practical course of action. So we shift our model to describe the situation. So let me summarize in the manner of Nagarjuna. Normal mathematics, as opposed to formal mathematics, is neither certain nor non-certain. So because it is neither exact nor inexact, since you accept pratyaksh praman with zeroism, it is not certain. So it is not as uncertain as a proposition that a rabbit has horns. Likewise, calculations such as square root of 2 can never be done exactly. But it is not as inexact as saying square root of 2 is 21 or something like that. So it is neither certain nor uncertain, neither exact nor inexact, and that would be the position of zeroism on this. Now let me quickly cover one more idea of how mathematics connects to culture when people talk of aesthetics in mathematics. Is there any aesthetics? Is there any beauty in mathematics? Now, Plato believed that mathematics, like music, arouses the soul. And this is discussed in great length in this book and in various other things. That mathematics, the word mathematics derives from mathesis, which means learning. And learning, according to Plato, as he states in Meno, through Socrates, or as Socrates states, is recollection of knowledge acquired in past lives. That is what Socrates says. He has a dialogue with the slave boy, and he claims that the slave boy's knowledge of mathematics proves that existence of the soul. And Proclus, who is a Neoplatonist, 1,000 years later, says the same thing, that mathematics arouses the soul from its slumber. And therefore, Plato prescribes in his Republic. May I have water, please? Sleep. Sleep. Thank you. So we know that this notion of the soul was cursed by the church, discussed in great detail in this book, 11 Pictures of Time, which banned mathematics in the 6th century. And when mathematics was accepted back during the Crusades, it was de-linked from that Egyptian, Platonic, Neoplatonic, Indian notion of soul and related solely to reasoning. Why that happened, what was the politics of that, is a long story. But Aquinas talks of divine reason, and that notion of divine reason differs from Proclus' notion of divine reason. So, well, this is the book in case you could not see it. And this is the other book on 11 Pictures of Time, which deals with how these notions of time were transformed in Western tradition. That is very important for the purpose of science. So formal mathematics, it has no aesthetics. It is soulless in both a literal and a metaphorical sense. And how do we demonstrate that? If you see students today, children, they all like music. They always have this thing connected with the phone or whatever, and they are listening to music. But so many of them detest formal mathematics. They hate formal mathematics. So there is no pleasure in it for them. They are repelled by it. So what is the solution? Solution remedy is to switch back to normal mathematics from formal mathematics. That's the idea. So let me say, summarize again, that there are 4 noble truths in mathematics. There is much dukh today among mathematics students. All right. And the reason for this dukh is ignorant acceptance of Western formal mathematics without understanding its real philosophical basis. So the dukh can cease through right knowledge which rejects formal mathematics and its metaphysics of infinity as erroneous. And the way is provided by zeroism, which accepts as in normal math the empirical and so on and inexactitude. So it accepts lack of certitude and inexactness, both the things. So this is what I would like to suggest about mathematics, that this is necessary part of reality, and now this synchronizes it, this completely aligns it with the Buddhist philosophy of mathematics and some other points, that it makes mathematics very easy. And this has been demonstrated in actual teaching experiments with 8 groups in 5 universities in 3 countries. I taught calculus without limits as it developed in India with Aryabhat. And the first experiment was in Sarnath. So like the Buddha, my journey also began from Sarnath. So this was a course that was taught many years ago, I think around 2009. And the students, some of them were very happy. They understood what had happened. And the idea was that in 5 days, one would be able to teach calculus to students who had at least an 8th standard background. Unfortunately, some of those students did not have that 8th standard background. There was a little difficulty, but we got over it. Then this was taught in Tehran, again to a general group. It was taught in Ambedkar University, Delhi. And this group of people were very happy, the students, because they were social scientists, they were economists. And they had dropped mathematics because they were unhappy with mathematics. And this is Al-Bukhari International University, Malaysia. So there are other courses. Calculus Without Limits is not the only course, where I cannot go into everything. Zeroism ideally suits probability, as it again developed in India. And hence there is a course on statistics for social science, which has been devised. There is a course on string geometry, as in the Shulba Sutra, for class 8 students, because it clarifies the concepts of calculus and trigonometry much better. Okay, so the references, that book is there, Cultural Foundations of Mathematics. And there is a full list. If you see this, the long list, I think I will not move out from this presentation, but it is available on the net. All right, if you search for it, or I will show it to you just now, at anybody wants the details, of course I will leave this URL here. So the other part is that it makes mathematics better. Students are able to do harder problems. A simple example is that, well, I will skip this, that it doesn't have, they can do harder problems. A simple concrete example is elliptic integrals. They are not taught as part of any calculus course, because calculus only deals, as taught in universities, only deals with elementary integrals. This is a non-elementary integral. But it is needed for doing science. The first experiment in science involves a simple pendulum. And that simple pendulum, the time period, is given by an elliptic integral, which students don't know. So you can measure it You can see it, but you cannot calculate it because the mathematics is defective, as taught is defective. And so this has actually been done. It was in fact done by my son, and it is available as the Pendulum Project. This was done when he was in class 12. So if you Google Pendulum Project, you will get this. So just have to Google it, and you will get the entire theory as it was done. The observation and the calculation, and why that calculation is needed. Now, why better math? Better math leads to better science. That's the bottom line. Not just saying that we should do it because it is Buddhist. It's saying that we should do it because it leads to a better science. That's the point. So, again, there are cultural issues in science. Aquinas, he proposed the dogma that God rules the world with eternal laws of nature. Laws of nature. So this is there in Summa Theologica. Divine reason, and divine reason rules with eternal laws of nature. Why are they eternal? Because it is he's not subject to time. Divine reason. This is the claim made by Aquinas. And okay, I think I will skip that, but the real problem here is that there is a dogmatic belief that only God is capable of creation, and that creation happens only once. That is not the belief in other cases. It's not the belief in Islam. It's not the belief in Sufism. It's not the belief in Neoplatonists. It's not the belief among Gnostics. And certainly it is not the belief among Buddhism. You allow that there is continuous creation, that you are in a way able to create the future. This is what you observe. So there were debates between Buddhism and Jainism on this issue, and this is well known. So the point is that laws of nature is declared as, belief in laws of nature is declared as essential to the ability to do science. And this particularly has been applied against Islam. Islam does not believe in laws of nature because Al-Ghazali rejected that belief. I have a long article on Islam and science, and I have given several lectures on that. So you could take a look at that. I'm not going into it. I'm only saying that you are obliged to believe. There is a normative view that in science, to do science, you must believe in laws of nature. And Buddhism could be similarly attacked tomorrow because Paticca is not laws of nature. It is something that human beings are doing, something that living organisms are involved in doing. Now, what are the laws of nature? They are written down as differential equations in current physics. Newton's laws, whether mechanics or gravitation, Maxwell's equations, or Hilbert-Einstein equations, or even Schrödinger equation. It connects. What does it do? Forget about what these equations are. Let's not write. What does it do? That the present state of the cosmos decides all past and future states. This is what these equations tell us. These equations are formulations of laws of nature in terms of mathematics, and what they say is that all past and future states are decided by the present state of the cosmos. But this is contrary to our everyday observation. I decide whether I'm going to drink water at the next instant. I decide that. Small thing, but I can do those small things. And that observation should be compatible. Science should be compatible with that observation. Because science has to be compatible with observation and not the opinions of scientific authority. But existing science can be made compatible. It requires, and we should not have to talk about free will because that's a theological discussion. And we should be able to discuss compatibility of science and observation without bringing in theology, because it's just between science and facts. So is it possible to reformulate science to make it compatible with mundane observation? Yes, it is possible. That also makes it compatible with Paticca. That's the central argument that I would like to try and explain. I don't think I can explain everything because it's a very long thing. I will just go into it. But this is essential because human actions cannot otherwise eliminate dukkha. It's very central to Buddhism. So we want that. So it is easier to understand this perhaps in a historical perspective. Differential equations use the calculus. Calculus, as it was invented in India, was translated and sent to Europe in the 16th century. So there is all the evidence for that compiled in this book, Cultural Foundations of Mathematics and the Transmission of Calculus from India to Europe in the 16th century. But the point is, it is not that we did something very glorious. Yes, we did something glorious, but that's not the issue here. The issue here is that Europeans did not understand the Indian calculus, Indian method of summing infinite series. It used non-Archimedean arithmetic. See, this is not the only case. Whenever information is transmitted from one region to another, there is lack of understanding. And this happened with everything. It happened with algorithms, it happened with numbers, it happened with sine, cosine, trigonometry, with calculus, with probability. And there are details of that. I gave a talk at MIT which covers all this in great detail. And there is an abstract, there's a video, there's a presentation available. So maybe you can take a look at that. It gives all the details available. And if you forget the link, you just go to my website, ckraju.net. There you will find all these links. So what's the point? How did they happen? I'll just try to briefly explain why did they misunderstand calculus. See, Aryabhat, when he developed the calculus, and he calculated a value of pi. What is pi? If I have a circumference of a circle, circumference, the ratio of circumference to diameter. Well, this developed into an infinite series. But the circumference and diameter of a circle are empirical things. I can see the diameter. If I draw a circle, I can see the circumference. I can see the diameter. But if one rejects that, one is left only with the infinite series for pi, which developed by the Kerala school. Maybe he will be talking about it. I presume he will be talking about it some more. Now, one cannot sum that series infinitely, so you have an inexact value. And therefore, Descartes said that, he said in his geometry, that it is beyond the capacity of the human mind to understand the ratios of curved and straight lines. Now, I can use a string, and I can measure a curved line. It's a flexible string. I can straighten the string, and I can measure a straight line. So with the beyond looking only at the infinite series. And in understanding of calculus led to the failure of Newtonian physics. That Newton believed in laws, we speak of Newton's laws. And he wrote laws. In fact, in his own notes, he cancelled hypothesis and wrote Lek. And those notes are available in the Jerusalem National Library. But the point is, he thought that those laws, because they are eternal, must be written in the perfect language of mathematics. Exact, perfect. How do you achieve perfection? So to achieve perfection, he thought, because he needed a derivative with respect to time, he thought that you must make time metaphysical. And perfection lies only in metaphysics. And that is how it is still taught. Calculus is still taught when we talk of real number system. That is metaphysics. We teach that if you want to derivate, if you want to differentiate, then you must have the notion of real numbers. So Newton thought that time itself must flow. He had a theory of fluxions. It was a slightly different theory. It was not the same as real numbers. And this is what he said in his Principia. Absolute, true, and mathematical time flows on without regard to anything external. 4 adjectives to describe that time must be metaphysical because it is perfect, because he is writing down the equations, the laws of God in a perfect language. Now,
times are 2
How do you actually identify time? What is actually the meaning for all?
yeah, I have 2 books on the subject. All right. So it was difficult to summarize. All I'm saying is that time flows. Newton said time is metaphysical. It is absolute without regard to anything external.
perfect sage or what see in a carina. This is the Jungiamares, Chitan Sujan sage of the Jungiamares. Till in David in this during which he was the Takunza Nujob Manguji, Larry Larry. Dindi ju dini kang khabu chagdu yores. Jidu tanda di jagar dang ta nubjo be pen tanda kon zeroism ta si de war tungba ni soru. Tuzu hingen ji ina. Ene cho jing ne perfect sin sha mu tup ken ji yores. Kas ne tuzu di pen meta be ran hi tungba ni ran hi du ko lamsan gyu du gen jigla. Dire se ngue sung khabu ji yore de ina kala kasam ke dembe ran hi ji kha tu yores. Ta di kon ju ni ke malen ji nubjo bu kharan su ge da be de che de dembe ji gu du se ta ben formal mathematics ina du che ne. Ene di karso da thanglin deba na diri ngecha lemne nyokdo nam chuyore se ra chiri.
So this was a conceptual error, trying to say that time flows. Fluctuations means flows. And this has been discussed in Indian tradition. Sri Harsh, who takes from Nagarjuna, in his Khandan Khanda Khadya, he discusses this, which is also today called McTaggart's paradox in the Western philosophy of time. It is discussed in Buddhist books. It's discussed in this book initially, all those things. So time cannot flow. Things may flow in time. How can time itself flow? If time itself has to flow, there must be a second time with respect to which it flows.
Time is in your mind, right?
No. Time is in your mind only if it is metaphysics. Time is out there in physics. If I am writing physics, if I am doing physics, I am coming to that right now. So because Newton put it in his mind or in God's mind, he made it metaphysical, therefore his physics failed. Because to do physics, I must be able to measure time with a clock. And because Newton did not specify a clock, he said time is in God's mind, therefore Newtonian physics failed. And that is what is discussed here, that because he did not define a clock, therefore it failed and it was replaced by the theory of relativity.
The clock is made by you.
Yes, it is made by us. We have to define it, but we have to define it in order to do physics, which must be refutable. If I speak of uniform motion in Newtonian physics, how do I know what is uniform motion? And if I don't know what is uniform motion without a clock, equal distances in equal times. So I must know what is a clock. And if I don't know what is a clock, then it is not refutable. Is it your heartbeats or mine? Something which is uniform motion according to your heartbeats is not uniform motion according to my heartbeats. Therefore, it is not refutable. If it is not refutable, it is not physics. That is where it failed. And that's what happened. So this led to the theory of relativity, where a clock was defined using the speed of light. You can change it. But you must define a clock in order to do physics, in order to be able to measure the thing. As Isaac Barrow, Newton's mentor, said, those who do not define a clock, who do not define time and do physics are quacks. He was referring to Augustine, who said, I don't know what time is. Quack.
Zuma.
So the point is, a little noticed consequence of relativity is that after relativity, you have to use something called functional differential equations. I have a series of 6 articles in physics education recently explaining functional differential equations. They were first formulated in this book. What is the point? What is this functional differential equation? What are we achieving with it? Okay, so let me explain in brief. That with the earlier thing, we are talking of laws of nature using ordinary or partial differential equations. The present state decides both past and future states of the cosmos. Functional differential equations is just a mathematical thing, not some hypothesis, but just a correct way of which I will consider retarded and of mixed type. With retarded equations, the past decides the future, future does not decide past.
But can you explain this functionality?
Functional differential equations is a coupled ordinary and partial differential equations, where the state at now depends on the state in the past. Past is involved, not just the present instant. So it depends on the past, possibly also on the future. With retarded equations, it depends only on the past, and therefore the past determines the future, but not other way around. With mixed type equations, past conditions the future, but does not determine it. So that is the model that I have proposed, that it could, it's not something completely, not that a book will suddenly turn into a horse. No. The future is conditioned by the past, but not determined by it. This is most important, and that is part of the physics there. So one possible case is if we correct Newtonian gravity. So Newton's gravity fails. This is my retarded gravitation theory. And it improves on Newtonian gravitation even within the solar system and also in the galaxy. Improves on general theory of relativity, which cannot be applied to the galaxy. I won't go into that. There is a reference in physics education. It's an expository reference, pedagogical reference on retarded gravity. If somebody wants, you can go into more details. But this does not really involve any new hypothesis. It is part of existing science. We are dropping hypotheses. We are dropping some metaphysics. I'm not saying believe this because I want to speculate. I'm not speculating. I'm saying within current science, this is the best way to do it with mixed type equations. So this is where Paticca Samuppada comes in, that if you have mixed type equations, the future is conditioned by the past but not determined by it. And this is a logical consequence of doing the mathematics correctly, of doing the physics correctly. And, well, various people if you see in Islam also, there is something similar. When you speak of continuous creation, it is conditioned by past habits, but not determined by it. It's not laws of nature. And similar beliefs about creativity among Neoplatonists and Gnostics and so on. This creativity is of central importance from the point of view of Paticca Samuppada. Last point that I will make is that quantum mechanics and Chatushkoti, if we do this, I have not mentioned quantum mechanics, I'm not going into it. This book offers a new way of doing quantum mechanics. What happens is that if you have mixed type functional differential equations, you get a structure of time. If I'm doing calculus, I assume that time is like a straight line and everything must be done with that. But time may have a structure. There may be multiple streams of time, and such as multiple streams of time naturally arise. If there are multiple streams of time, logic changes. One way to understand that is with a parallel processor. This computer may have several processors which are simultaneously processing different streams. And if I want to deal with such a parallel processor, I was in CDAC and we helped to build the first Param supercomputer. People used to ask, can you give us a debugger? If you break the state of the system at one instant, you don't get a unique state. And because there are multiple streams in one processor, Schrodinger's cat may be alive or it may be dead. So logic changes. And that change in logic, which is discussed here, I called it quasi-truth functional logic, is the same as Chatushkoti. So the whole thing gets tied up. You have Shunyavad, you have Paticca Samuppada, you have Chatushkoti. It gets tied up very nicely, very neatly. And this is also relevant to future technology of quantum computing. I'm not going into Shield, because I don't think I have enough time. There is a paper I have written on harmony principle, which connects this. It is published in Philosophy East and West. It is also explained here. So maybe you take a look at that. It is, I cannot explain everything right away. Let me summarize. So religious dogma has crept into mathematics and science. The belief in certitude and exactitude of mathematics are dogmas, as is the belief in eternal laws of nature. Any comparison of science and religion must take this into account, that there are cultural elements there, within mathematics, within science. For an objective comparison, one must, or for at least a fair comparison, I don't want to use the word objective, we must reformulate both mathematics and science to eliminate those dogmas. This has been done, but it needs to be made more widely known. And and this change in mathematics and science needs to be brought into educational practice, as we have tried to do, but it needs to be brought into educational practice. So summary of mathematics is, again, I think I've already said that there is much dukkha in present-day mathematics. I wrote an article on making math easy, and I got hundreds of letters from people said, my child is very bad at mathematics, please do something. Now, I don't have an individual solution. I have a collective solution. So it's a system which has to be changed, and that is what we must start trying to change. And we can do that if we do mathematics with zeroism. And it needs to be brought into mainstream education. Zeroism changes the philosophy of mathematics by accepting fallibility, by accepting inexactitude. It's neither certain nor non-certain, neither exact nor inexact. It agrees with the actual mathematical practice and makes mathematics work better. So once more, the idea is that not just because it agrees with my whatever leanings may be, but because it works better also. Okay, the science I think I can skip because I've just said it, that if you modify science, if you give up the dogma of laws of nature, then you get a science which is closer to paticca-samuppada. And also gives you Chatushkoti. So I will stop with, I'll skip Chil, I never talked about it really. The changing education in terms of practical, concrete steps, we want to decolonize education and change it. That has been what we have been trying to do. And there is a lot of, because the education system, complete education system has to change. And we have tried this. Calculus Without Limits is one course. We tried History, Philosophy of Science, teaching it differently. That's another course. And string geometry, statistics for social science, and so on. So let us start teaching mathematics like that. Let us start teaching, at least in Buddhist institutions. At least in Buddhist institutions like Nalanda or Sanchi or in Taiwan or in Thailand and so on, at least let us start teaching there. At least let us introduce a course on Buddhism, science and technology, which explains to people what these possible connections are, what these possible biases may be, and which could be later expanded to teach also science with paticca-samuppada. Thank you very much.
I thank Professor Raju.
Your lecture, creates deeper knowledge, but for me, more confusion. So instead of that, more dukkha.
I am grateful to Professor Raju for giving us some very concrete and practical proposals at the end of a naturally very abstract for non-mathematicians expose. And I actually realized that I forgot at the beginning to request His Holiness to make some opening remarks, but perhaps he would like to do so now. I know that we have some more minutes before the tea break for a discussion, but I would like Your Holiness to...
The very name here, Buddhism and science, actually last, I think, over 30 years, as you know. I start serious discussion, serious discussion with modern scientists, mainly 4 fields: cosmology, neurobiology, then comes physics, particularly like quantum physics, then psychology. So I see at the beginning, some people use this word, dialogue between Buddhism and science. Then I suggested this is wrong. We engage with scientists. The subject, when we say Buddhism, and then nirvana, Buddhahood, or these is I think very important part of Buddhism. So we are not discussing these things. Even we are not discussing with scientists about next life. Sometimes when we discuss about mind or different level of mind, then some sort of reference the innermost, subtle level consciousness. You see, there is continuation. So from that viewpoint, no beginning, no end. So sometimes you see that kind of that topic or that point sometimes you see connected. Otherwise, we never discuss about next life. As you know. And then, so I usually describe Buddhist science and modern science. Buddhist science means about physical and cosmology. These things you see mentioned there. You see, as a result of meeting with scientists, now some of our sort of belief is outdated. So some certain sort of concept, I'm Buddhist monk, I publicly sort of, reject. These are not true. Scientifically, we can prove does not exist such thing, such as Mount Meru, like that. But then cosmology, you see, not just Big Bang once, no beginning. And every particle is a substance, you see, no beginning. If there is beginning, then certain things without cause must come. The cause, there are conditions, cooperative condition, and then substantial sort of cause. So, as far as the substantial cause must be same nature. So, like consciousness or some other particle, there must be, you see, continuation of previous sort of cause. So, from that viewpoint, even before Big Bang, just empty space, this very, very subtle level particles there. 가서 따봐 시야시 가서 되면 가서 다 정말 기지 용서부터 뒤 따봐 뒤 따봐지 가서 되면
A permanent subtle particle, like for example.
something like that some non-Buddhist school taught also you see believe that. So this is sort of similar view, no beginning, like that. Then, see, it is quite obvious. If you believe just Big Bang once, then we have to sort of think, what's the causes of that tremendous sort of explosion? Without cause, you see, we can't, it cannot sort of take place. So there must be certain sort of substance to produce immense sort of pressure, right? Then explosion, you see, take place. So that there must be some sort of particles. That particle also come from their own causes. So from that viewpoint, no beginning. Similarly, consciousness also is no beginning. In any way, cosmology and neurobiology, you see, we really learned very, very useful information from modern sort of scientific findings. Very helpful. Then, physics, especially quantum physics, the Nagarjuna, you mentioned the Nagarjuna's sort of, say, nothing exists objectively. It's very similar, quantum physics view and Nagarjuna's view. And meantime, so then psychology is concerned, I usually call ancient Indian psychologists, Indian knowledge about psychology, highly developed. So as a result, over 30 years of discussion with scientists, they really find sort of very, very useful to get more information about human mind, human emotion, and then the fuller knowledge about the function of the emotion, then much easier to tackle this destructive emotion, like that. So what I usually call science of Buddhism, or Buddhist science, mainly science of mind, and then modern science, like that. So that I usually see, I mean, because of the actually feel like that. So Buddhism may be too big word. Okay. So therefore, now I really appreciate which is such because of the meeting. I really admire, you see, your knowledge, much depth. So as I briefly mentioned, the two-tooth, kasa, tempani.
Yeah.
Two truths. Samriddhi Sadhya and Param Art Sadhya.
Oh, so the very reason two-tooth, you see, concept of two-tooth come is there is sort of big sort of gap, appearances and reality. So itself sometimes contradiction. But then the Nagarjuna's, I think, a unique thing, you see, he often use the why things does not exist objectively. You see, he used the reason Patita Samupanda. So Patita Samupanda means there is something, but due to other factor, not by itself. So when we analyze things, objectively, what's there? Nothing can be found, because objectively nothing exists. But that does not mean nothingness, but there is thing. It worked. So you drink a lot of water. You see, it is true. If we investigate what's the water, before you taking water, if you investigate, you can't find water.
Yes, please. Thank you.
So I think the concept of truth, not only just Buddhist sort of Buddhist tradition, but at that time, I think all India's the philosophical views, you see, have this concept, you see, truth. So really wonderful, like that. So now last sentence you mentioned the existing education system. Of course, from different sort of angle, I also feel that my sort of view is the existing education system is very much oriented about matters or material value. Yep. So the whole generation who come through that kind of education, then eventually more sort of neglect about our inner value. So today, as far as modern education is concerned, it's much developed. And with that technology and many things, highly developed. But I think human suffering seems increasing. These wonderful human innovations, science and technology, these also now causing more suffering, more problem. So what is lacking? Sense of responsibility. And that also is very much related with sense of concern of others' well-being. And that's also the full sort of the conviction. We all same human being. I want happy life, do not want suffering. They also, according to my experience, they also have the same sort of wish and the same right. Therefore, if you accept, you see, 7 billion human beings have same right, then there is no basis to kill, to bully, to cheat, irrespective whether accept God or not, or accept Buddha or not, doesn't matter. Because of our very life should be more peaceful, more happier. Here, I think our prayer, sometimes is God or Buddha, also more or less fail to bring happy world. So now, our responsibility, you see, to create more happier world. Then Buddha and God, I think, certainly will please, because of much pleased. then I think they may give us more blessing. If we against God's wish, then I think God also feel a little bit hesitant to give blessing. So sometimes I usually say, telling, you see, if we have the opportunity to see Buddha and Jesus Christ and ask, please bring peace on this planet, then I think Buddha and Jesus Christ, I think, may tell, who creates this violence? Who destroys peace? Not Buddha, not Jesus Christ, but you human being. So you have the responsibility to solve, to reduce this problem, since you created. So our education system, I think, not adequate. So that's my sort of view. So I really appreciate. I really hope in future, Mind and Life sort of conference, I think some cases, I think you should come. Then, as I mentioned earlier, I wish to create more confusion. That I really used to want. Thank you.
I believe that the floor is invited to make some comments or raise some questions, if there are any.
I have a couple of short comments. You mentioned a couple of times. You would like to use
Microphone.
Cha kadure. Cha. Ka.
I think it's in 10 minutes, right? We have 10 minutes.
Okay, you mentioned a couple of times the inexactitude of mathematics, the square root of 2, it can never be precise. And you mentioned several times the lack of precision of... And actually in the science I represent, life science and also physical science, science gave up long ago the idea of being exact. You know, science cannot be exact by definition. If I let this pen fall, I can calculate exactly the speed given the mass and given. But doing so, for example, I neglect the friction. I can put in my equation the friction, but then I neglect the fact that in the time the Earth moved a little bit, so I should keep that in. Then I should keep some principle of relativity. And you know, it never ends if you want to be exact. Cannot be done exactly. And the whole point is that you do what you do with science depending on what you want to do. So for me, it's enough, you know, approximately to know the speed. And I don't care about the second, third, fourth, fifth decimal. I don't care about the precision. The same with biology. And I think science cannot any longer be defined as something striving for absolute precision.
May I make an intervention here? I did not say science tries to be exact. I said mathematics, formal mathematics, claims to be exact. That it claims that if I do a calculation on a computer for science, that is inexact, that is erroneous. That is the point. Science cannot be exact. Science accepts. Physicists accept what I say. They don't have a problem. It's the mathematicians, formal mathematicians who have a problem.
The same for... The same for objectivity, but I come to that on my talk. And I have a final question to you, which is a little, you know, a bad one.
No problem.
An old philosophical question. For you...
So first, I think I would like to know What is the definition? Bad and good.
Bad is when is put into trouble. And the question is, for you, mathematics, is a discovery or an invention? You know, America has been discovered, was already there. Differential equations have been invented, they were not there. Mathematics in general and geometry, it's an invention of mankind or was already there, you know, as archetype or in nature. It's an invention of man or not?
Well, I already answered it in my, I think it's obviously an invention. So we are talking about, I mean, it is a Platonic theory that it is up there is some truth up there which you have just discovered. So I am not claiming that at all. I'm saying there is a reality there which you are not discovering, which you are trying to describe. Okay, and which you are discovering, trying to describe, which you are inventing in your description of it. So for example, when Aryabhat will give something, it's an invention. It's out there, you see it, and you describe it. So you have a model. So according to me, mathematics is an auxiliary physical theory. It is as much an invention as any other physical theory. It's not a discovery. So that discovery is Platonic. It talks about your soul. It talks about the discovery of the soul and so on. Brings in a whole lot of categories which I am not bringing in here. All right? So not so bad.
If there is no other comment, perhaps, with Your Holiness's permission, we could break for tea, because I think we have reached...